Okay, next thing that we're going to deal with is calculating the oxidation numbers for elements that maybe we don't know what the charge is, okay? Now at first, this isn't going to make a lot of sense as far as why we're doing this. You just might feel like you're doing some trivial exercise. But when we begin naming compounds, it's extremely important to know the oxidation number or the charge for your elements, especially your transition metals. So what do we know for sure about oxidation numbers? Well, there are several known oxidation numbers that don't change. In fact, if you look at your periodic table, you'll notice that directly above the symbol there's a number, okay, and it's a little small bold number, and that gives you what the charge is for that element. For example, look at potassium, K, that's atomic number 19. There's a little 1 directly above the potassium. That means potassium always has a positive 1 charge. Barium is Ba, it's number 56. If you look right above Ba, there's a little 2. That means barium will always have a positive 2 charge. But then let's drift over a little bit into these transition elements. Let's look at cobalt, okay? When we look at cobalt there, it has 2 numbers above it. It has a 2, which means it either is a positive 2 or it shows that it could be a positive 3. Now the one that's in bold, which is the positive 2, is what it most commonly is, but it can also be a positive 3. So it's important sometimes for us when we're naming to find out which one it is. Now let's look over at the nonmetals. Let's look at fluorine. You'll notice that fluorine is always a negative 1. That's F, okay? It's number 9 atomic number wise. Oxygen, it's either a negative 2 or a negative 1. So there's some more options there. But look at chlorine. Chlorine can be a positive or negative 1, 7, 5, or 3. So there's a lot of differences there. So let's go back to what we know for sure, okay? We know that group 1 is a positive 1. We also know that group 2 is a positive 2. Hydrogen is usually always a positive 1, except when we have something that's known as a hydride, where hydrogen is on the right side of the formula, and that will end up being where the hydrogen actually is a negative 1. Almost always, though, we can assume that the hydrogen is a positive 1. Oxygen, we can almost always assume it's a negative 2. There are some exceptions that are called peroxides where oxygen is a negative 1. They will be rare. Now, these next 3 rules are big for helping you out, okay? Because when you look at the periodic table, it's not going to give you this information, okay? Now, group 17 will always be a negative 1. Here's the key. When it's with a metal. Now, remember, metals are on the left side of the zigzag line. So group 17 will be a negative 1 when it's with a metal. Group 16 will be a negative 2 when it's with a metal. Group 15 is going to be a negative 3 when it's with a metal. Now, how do we then figure out if we have some unknown charges for an element? How do we figure it out? Well, first off, place the oxidation number or charge above each element that you know for sure. Make sure you check the above rules. Then we're going to multiply the number of atoms of each element by the charge to get the total amount of positives or negatives for each element. And all of the charges will end up adding up to 0. Now, if we have an unknown element, obviously we can't put in a charge for it, and so we have to put X. We use the X just as a variable. It doesn't matter what variable you use, but we're just going to use the variable X. All charges, again, must add up to 0, and we're going to solve for X. Now, that probably doesn't make a whole lot of sense at the moment, so let's go ahead and go through this, okay? I'm going to just do some examples here. If I have H2S, okay, we've got hydrogen and we have sulfur. Now, look up at the known oxidation numbers. Well, I've got hydrogen, and I said that hydrogen is always going to be a positive 1. Okay? Now, the sulfur part, it's in group 16. However, it's Group 16 will be a -2 when it's with a metal for sure. So we don't know for sure, so we need to do some work here, okay? And so what we do is we put our known charge up above, which is a +1 right here. Then we need to multiply by that amount, okay? So we take our 2 times our +1 plus I have 1 sulfur times the charge of the sulfur. Now we don't know that for sure, so we just say it's X. And that adds up again because there's no overall charge at the top when we began. It adds up to 0. So then I have 2 plus X is equal to 0, sulfur X. And so X is -2, so the charge of sulfur in this case is a -2. Now, let's do some that require a little bit more work here, okay? Let's do copper iodide, okay? So CuI. Now, in this case, we have copper, and copper is a metal, but we don't know the charge. Iodine. Now, iodine is in group 17, and when you have a group 17 with a metal, we said that the charge is -1. So let's go ahead and let's put that up here, -1. Now we don't know the charge for copper, so we're just going to put an X there, okay? So we know that there's 1 copper times the charge, X, plus I have 1 iodine times the charge, -1, is equal to 0. So we have X minus 1 is equal to 0. Therefore, X is equal to +1. Now, some of you may have been able to do that in your head. That's fine. Go for it, okay? I'm going to do one here, though, that's not quite as easy. And that involves something more like HClO4. So let's try this out. Okay, well, which ones do we know for sure? Well, we have to not know only one of them, okay? So that's going to help us out a lot. And we know that hydrogen is always a +1. Chlorine is not with a metal here, so we don't know what it is. But oxygen we know is a -2. So here's what we're going to do on this then. Again, we take the amount of hydrogens that we have, and let's put the +1 up at top. This is an X. And then this is a -2. And so I have 1 hydrogen times the charge, +1, plus I have 1 chlorine times the charge, X. Okay, and then plus 4 times the charge of the oxygen, which is a -2, all adds up to 0. Now, if I can simplify that right down here, that gives us 1 plus X minus 8 is equal to 0. So, if we do that, that means that X, solvent, is a +7. So in this case, chlorine has a +7 charge. A little more difficult there, isn't it? Let's try one last one, and I'll send you for a doozy, and we'll call it good. Let's look at, let's look at one that has a polyatomic ion. NiCrO4. Now, in your homework here, it's got Ni and it's got CrO4. Now you should recognize that this right here is a polyatomic ion. So circle the whole thing, okay? That whole thing, we have 1 of that whole thing, and that whole thing has a -2 charge. Now, you should be thinking right away, okay, if this is a -2 on this side, then nickel has to be a +2. And that's true. If we would have done it that way, here's how we would have found this. Nickel would have been X, okay? And so I would have would have had 1 times x plus 1 times a negative 2 is equal to 0. So I have x minus 2 is equal to 0. Therefore, x is equal to a positive 2. And that would be my charge of my nickel. So polyatomic ions, treat them as a whole unit, and recognize that you only have more than one of a whole unit if there's a parentheses with a number outside. Hopefully that'll help you out, and hopefully I haven't confused you more, but that's a little more on how to calculate oxidation numbers.